Okay, if you are in 7 Excel, we are working from the Advanced 2 textbook. If you are in Math 8, we are working from the Course 3 textbook. We are doing lesson 4.4, example 3, and it can be found on page 169. Okay. So we're not doing any new math. We're just interpreting the math that we've been doing. So here in this problem, it's telling us the cost Y in dollars of taking a taxi X miles is Y equals 2.5X plus 2. A, graph the equation, and B, interpret the y-intercept and the slope. Okay. So the first thing we need to do, I know that slope-intercept form is y equals mx plus b. This is slope-intercept form. And it makes graphing a lot easier. So the equation that they've given us is y equals 2.5x plus 2. Thankfully, this is in slope-intercept form. It lines up. Perfect. The problem also tells us that y is dollars. We know that 2.5 is the slope. It tells us that x is miles, and we know that this is our y-intercept, and our y-intercept is when x is set to 0. Okay? Okay, so there's one other thing. We want our slope to be a fraction. We want our slope to be a fraction because we know slope is rise over run. And they've given us 2.5. So we have two choices. We can say 2.5 over 1, in which case we're going to be dealing with like in-between marks on the, in-between tick marks on the coordinate grid. Or we can say 2.5 is equal to 2 5/10, which is equal to 2 1/2, which is equal to 5/2. We can use this fraction or we can use this fraction. You will get the same answer either way. It's up to you. With this, you're dealing with whole numbers. Here, you're going to be dealing between tick marks. So either is fine. Okay, I'm going to rewrite this with my slope as a fraction because this is my rise over my run. Okay, now they asked me to graph this. I can do that. Okay, this is my x, and they told me x was miles. Here's my y-axis, and they told me my y-axis is dollars. It's important to label all of this stuff. Okay? I'm going to start with my y-intercept. My y-intercept is positive 2. So when my x is 0, my y, where my line crosses my y, is at positive 2. Now, I'm going to count off my slope. My slope is 2.5 over 1. So I'm going to go up 2.5 and over 1. I'm going to go up 2.5 and over 1. I'm going to go up 2.5 and over 1. So here's part A. They asked me to graph this. I have graphed this. Okay. Part B, they asked me to interpret the slope and the y-intercept. So I'm going to start with slope. I know slope is rise over run, the change in y over the change in x. In this case, y is dollars, x is miles, and my slope is 2.5 over 1. What does that mean? Well, it's going to cost $2.5 for every 1 mile. So it costs us $2.5 for every 1 mile. This is my slope. But they also asked me to interpret the y-intercept. So what is my y-intercept? Well, my y-intercept means at 0 miles, it costs $2. At 0 miles, it costs $2. But what does that mean? It means there is an initial $2 charge just for getting in the taxi. When you get in that taxi and you close that door, before you've traveled, it's going to cost $2. So you're not starting at $0. You get in the taxi, you close the door, it starts at $2. Then it's $2.5 for every mile. So we have created our graph, we've interpreted the slope, and we've interpreted the y-intercept. So there's no new math here. We're just interpreting the math we already know how to do. And I see a note here. It says I did it wrong. You pay $5 for every 2 miles. That is correct. $2.5 for every mile would be the same thing as $5 for every 2 miles. Same thing. Okay, let's do one more example. It's not new math, it's just interpreting the math we already know how to do. Okay, in this problem, the cost y in dollars for making friendship bracelets is y equals 0.5x plus 2, where x is the number of bracelets. They want us to graph the equation and interpret the slope and y-intercept. Okay, the best thing you guys can do for yourselves is to take the time to label everything. Y equals mx plus b. This is slope-intercept form. The equation that they've given us is y equals 0.5x plus 2. They told us Y is dollars. We know 0.5 is our slope. They told us X is number of bracelets. And we know +2 is our y-intercept. And our y-intercept is when X is 0, we're going to cross the y-axis at 2. We also know we like our slope to be a fraction. So I have two choices. We want our slope to be a fraction. So I've got two choices. I can say 0.5 over 1 or 0.5 is equal to 5/10, which is equal to 1/2. I can use either one of these. This means I'm going to be dealing with marks between my ticks, between my tick marks. This means I'm going to be dealing with whole numbers. Either is fine. You will get the same answer either way. So y equals 0.5 over 1x plus 2. Rise over run. This is just kind of a reminder. Now we need to graph this. Okay, we can do that. They told me X is number of bracelets. Y is dollars. So I'm going to start with my y-intercept. When X is 0, Y is 2. Now I'm going to count my slope. I'm going to go up 1/2 over 1. Up 1/2 over 1. Up 1/2 over 1. So first part of the problem is done. I created a graph to represent this situation. But part 2 asks me to interpret the slope and the y-intercept. Okay, my slope is rise over run, change in y over change in x. Y is dollars. X is number of bracelets. And my slope is 0.5 over 1. So we need to know how to read that. It costs $0.50 per one bracelet. $0.50 per one bracelet. 50 cents per one bracelet. Now, if you had chosen to use 1/2, it would be $1 per 2 bracelets. It's the same thing. $1 per 2 bracelets. So our slope has been interpreted. Now we need to interpret the y-intercept. And the y-intercept means when X is set to 0. So 0 bracelets cost $2. So when X, number of bracelets, is set to 0, it costs $2. But what does that mean? How can 0 bracelets cost $2? It means there is an initial $2 charge to start making bracelets. So to start, maybe there was like a cost in equipment, or maybe this is the postage. It costs $2 to mail a bracelet. So you have to pay the $2 up front before I start making bracelets. I don't know. But it means there's an initial $2 charge before you start making bracelets. So we don't have any new math here. We're just interpreting the math we already know how to do.